Americans at work. Men and women of the International Association of Machinists, AFL-CIO, whose everyday job is to fashion the wings that make man master of the air, as well as of the land and of the sea. Aircraft workers perform new miracles daily, fabricating metals that lie heavily within the earth into the matchless shapes that can soar as high as our dreams, carrying us in ever greater numbers. Behind every passenger and every member of a flight crew of a modern plane, there are hundreds of production workers. During World War II, when we needed great fleets of fighters and bombers overnight, production methods were developed to meet that need. The workers on the assembly line increased their output in both speed and quantity and built the aircraft industry into one of the nation's largest. Today, as more of us take to the air oftener, over 750,000 workers of all kinds are needed to produce enough planes. The bulk of the work in manufacturing an airplane takes place in an airframe plant. Here the ship is designed, parts fabricated, assembled and tested until the complete aircraft is turned out. Thousands of different parts are produced by cutting, forming, heating and processing such metals as stainless steel, aluminum, titanium, and aluminum alloys. Before the riveters and other metal workers can begin to bring this most nearly living thing among vehicles to life, machinery and tools have had to be moved into place. Operations worked out for making each part. Materials and parts made ready for the worker's hand. As the fuselage begins to take shape, the wings and tail sections are nearing completion. Some of the new jet giants have had to have facilities newly constructed for their assembly. This transport that will be nearly 130 feet long, almost 4 stories high over the tail, with a wingspan of 120 feet, will take up a construction area of more than 1 million square feet. Before an aircraft is ready to fly, it is estimated it takes more than 60,000 subcontractors and suppliers in engine plants and parts plants to provide the thousands of components necessary for every phase of its operation. The assemblers must have a working knowledge of these components, too. These men are creating a colossus of celestial navigation, but it can never be more colossal than the qualities its makers have put into it. In addition to the 2 to 4 years of training it may take to learn the standard practices of their trade, aircraft machinists must keep mastering new skills to keep up with a science developing almost at the speed of sound. This jet airliner will have a gravity-defying weight of over 175,000 pounds at takeoff. Yet every fastening must be made with the precision of the jewelry in the tiniest fine watch. The worker deals with increasingly complicated shapes for spars, belt frames, bulkheads, and skins to save weight without losing strength. The airplane begins to look more familiar to those of us who have never been inside an assembly plant, as the thin aluminum skin is stretched tightly over the frame. How do we know it will work in the air? Because these workers allow themselves no mistakes. But any human error that might occur will be corrected by inspection, re-inspection, and testing. The simple rivet is as important as the famous horseshoe nail, for want of which the battle was lost. Special automatic riveters have been designed to locate, drill, countersink, rivet and broach, wing and fuselage skin and stringer panels. New machine tools are constantly being created to meet the manufacturing requirements of new model planes. Before the frame is entirely closed in, auxiliary equipment, such as fuel and hydraulic systems, is installed. Every connection must be perfect for a flow of fluids through a system of vessels and valves almost as intricate as the system of arteries, blood vessels, and waste channels of the human body. The precision of the worker's operation must approach that of the surgeon. The future safety of crew and passengers depends upon the accuracy with which this most complicated of plumbing systems is laid out. Control of wing flaps, rudders, and landing gear depends on the hydraulic and cable systems. Even at this stage, features are built in for the ultimate comfort and safety the passenger will take for granted as he relaxes, sleeps, and eats, or socializes in the luxurious lounges. Cabins are completely insulated against unpleasant sound and external temperatures. Although the woman's touch seems appropriate here, women have shown themselves just as adept at handling riveting machines, and they make up a large part of the workforce in the airframe plant. Progress accelerates. The aircraft assumes an increasingly familiar aspect as exterior and interior assemblies proceed together. Electricians install the vital electronic circuits that will respond to the touch of pilot and co-pilot. The gauges and lights for inside communication between working parts and the men in the cockpit, or front office, and communications between plane and signal tower are as important as the fuselage itself. The intricate delicacy of these operations is why such equipment is sometimes called the jewelry of the aircraft. These systems, as far as possible, are put together in units with a minimum of fastenings, connections, or ducts, and a maximum of accessibility. This technique makes it possible to replace entire assemblies that may need maintenance work with the least interruption in flight service of the airplane. A new engine, or power pod, as it is called in jet parlance, could be replaced in 30 minutes. Of all vehicles, the form must fit the function of the aircraft most perfectly, must be most perfectly adapted to the element in which it moves. It cannot stop in flight to find out what's wrong, as can the moving land-bound or waterborne vehicle. possible contingencies must be anticipated before a new model is put in production. That is why performance must be tested. Every possible failure learned at each stage of development. That is why man's fastest traveling machine may be the slowest between concept and realization. Why it may be as long as 3.5 years from design to initial flight. Workers in the aircraft industry, priding themselves on the skillful use of the most advanced tools and techniques of their craft, themselves insist on the highest standards of performance. They constantly strive to lower tolerances of all fixtures and to increase the aerodynamic smoothness of all surfaces. Testing of the landing gear by inspectors is typical of an operation repeated over and over again with sections, systems, and finally with the whole aircraft itself. The test program keeps pace as the stages of production proceed through the months. All parts of the wing, tail surfaces, fuselage, and landing gear are subjected to loads by means of hydraulic rams connected to the airplane by whiffletrees. These loads are much greater than the forces met in normal flight, but not than the load of responsibility carried by the worker. The supreme test of any aircraft is, of course, in the air. The supreme thrill, shared by aircraft workers and passengers alike, is when each bigger, faster one passes this test. You have seen these workers build and put into the air the latest of a long line of record-breaking aircraft. Their triumphs have been achieved through tireless effort in each new chapter of aviation history. All the skills, training, and experience of the men and women of the aircraft industry, including these who are members of the International Association of Machinists, AFL-CIO, will be tested in each plane's maiden flight, proving the ability of these Americans at work for you. Americans at Work, presented as a public service by the AFL-CIO. Next week, another interesting story of Americans at work. Americans whose skill and effort help keep our country great and strong.